Hi, this is Mrs. Bustamante. We're going to do question number 4 on the limiting reactant worksheet number 1. This is about as hard as these limiting reactant stoichiometry problems get. So if you can't do this type of problem, doesn't mean you're going to fail. This is the hardest it gets, because in this reaction, we have to set up the reaction before and the equation before we can do anything else. So that means we have to balance particles, we have to balance products, and we have to know how to predict our products all in one problem before we can even find the limiting reactant. So we're going to split this video up into a couple pieces. Okay, so first we're just going to set up our problem. It says when 0.25 grams of copper 2 chloride reacts with 0.64 grams of potassium iodide. So I'm going to write that on my paper right now. I'm going to write that I have copper Cu plus 2, chloride minus 1. The plus 2 came because they told me, and it reacts with potassium iodide. Potassium has a plus 1 charge from my periodic table. Iodine has a minus 1 charge from my periodic table, and it says they react. How many grams of copper iodide are formed? Well, I can look at this. I can see that I have 2 compounds, so I know that this is a double replacement reaction. That means copper and potassium are going to switch places. They give me a hint here because they tell me I form copper 2 iodide. So they react to form Cu plus 2 with iodine minus. And that means I also formed potassium chloride, plus, minus. Put my in there so I can write my coefficient in front. So that means now I have to do my add-in inventory where I count my atoms, but first I have to balance my charges in my compounds. So this 2 and 1 is not balanced. I need 2 chlorines, plus 1 minus 1 is balanced, so it's good to go. Plus 2 minus 1 is not balanced, so I need a 2 here, and this is balanced. Now I go ahead and count atoms. So copper, I have 1 on each side. Here I have 2. Here I just have 1 chlorine, so I'm going to try a 2 right here. That matches my chlorine, but I changed my potassium, so I need a 2 right here. My coppers are still balanced, my chlorines are now balanced, and my iodines are still balanced, so that means this is a 1 and this is a 1. Now I'm going to look at this problem. I'm going to try and think, what's my given? What do they want me to do? What am I looking for? Okay, so they tell me I have 0.25 grams of copper 2 chloride. That means my given is 0.25 grams of CuCl2, and it reacts with 0.64 grams of potassium iodine. So 0.64 grams of potassium iodine. It wants to know how many grams of copper iodine are formed. So I want grams of CuIT. That means my type of problem here is a gram to gram. We might also call that a mass to mass. And then the other thing I'm going to need to know for this problem is I'm going to need to know all my molar masses. I'm assuming you know how to do that by now, but it's where we take the number of particles we have in our compound and multiply it by the molar mass from the periodic table. So my molar masses, I'm going to need it for CuCl2, and I like to do that ahead of time, so I just have it. CuCl2 should be 134 grams per mole. Cu(I2) should be 318 grams per mole. And potassium iodine should be 167 grams per mole. That's what I need to get me started on this problem.